Hello students, let us continue our discussion. Moving on to the next topic, two-dimensional scaling matrix, how to represent the homogeneous coordinate system matrix representation for two-dimensional scaling. Recall the scaling. Scaling stands for resizing. Either you can enlarge the size of the existing object, or you can go for reducing its size, right. Recall the matrix contents what we have discussed earlier in the previous video, right, as well as go through the formula. So, here we have the scaling thing. So, I will just refer to it, right. This is what the scaling matrix as well as the formula. X dash, how x dash is obtained? X dash is obtained by multiplying the coefficient of x with the existing value of x, right. X dash equal to this is what we have discussed in the previous session. Refer to my previous videos. Okay. So, x dash, which is obtained by multiplying the coefficient vector, that is x s x, with respect to the original value of x in case of scaling. In case of translation, we are adding it. In case of scaling, we are multiplying it. So, for translation, we denoted the term as Tx. Now, for scaling, for the sake of convenience, we are denoting the term as Sx. Same is applicable for y as well. So, y dash is obtained by multiplying the term. Please remember, for translation, we are adding the term. We are here for scaling, we are multiplying the term. Okay. The term is translation vector. So, sorry, the term is here scaling vector content with respect to y. Right. So, y dash equal to y into sy. So, how to write the matrix content? Matrix is obtained as, say, it is a multiplication of two matrices, scaling matrix, in a multiplication with the original value, that is point x y. So, p dash is obtained as, refer here, S into P, where S is the scaling matrix. So, how to write the content of the scaling matrix? Scaling matrix contents are nothing but our coefficient values of x, y with respect to first row, second row also x, y, that is for x dash, and this is for second row is for y dash. So, check the first formula. You can treat it as formula number 1, equation number 1, equation number 2. Check the equation number 1 and write it in the first row. Check the equation number 2 and write it in the second row. So, what is the coefficient of x here? First parameter always represents x in the matrix. So, its coefficient is Sx, Sx is written, there is no y term. So, y term is not there, means 0 into y it is mentioned 0, is not it. Similarly, equation number, observe the equation number 2, this is second equation, right. Is there any x term? No, that means 0 into x in addition with y into sy, 0 into x. So, first content, I mean first element of the second row, which should be 0, second element of the second row will be the coefficient value of y, what is that? Sy, in multiplication with original value. What is the original value? X and y, is not it? So, if you know these things easily, you can write, if you represent them in the homogeneous coordinate system. Please remember, this is one of the very important topic, representation of the elements in the homogeneous coordinate system, both for 2D model as well as 3D model. Please remember, now we are discussing about the 2D model. Okay. So, 3 parameters are required. The 3 parameters, how to represent? The third parameter will be 1 only, is not it? So, refer here, x dash, y dash, and third parameter is considered as 1. So, first 2 row contents, first 2 row and 2 column contents are same. We are copying it from there above. What is that? Sx and 0, 0 and sy. Third parameter, you are neither adding any value nor subtracting any constant value, is not it? So, you are neither adding the constant value nor subtracting the constant value. The third parameter should be 0 and 0. Go for the third row for parallel plane, the last parameter should be 1. This will be constant throughout our discussion, right. So, this parameter, as you can see above, refer to my previous videos. The third parameter always here, see, for here I have already marked for rotation, same thing is applicable for the translation as well. Okay. The representation of the original point, that is P, is the same. How? X, y, and third parameter as 1. So, this is what the scaling matrix is. Okay. watch the videos again, note down all the things, very important topic it is. So, note down about the homogeneous coordinate system, translation, rotation as well as scaling. Okay. For your reference I will tell you the page number as well. Page numbers, if it is not properly visible in the video, you can refer to the PDF. So, as per the PDF it is page number 39 and 40, 39, 38, 39 and 40 you refer to for okay. Note down the things for the 2D system. Later we will be discussing about the 3D as well, but 3D contents, those things belongs to module number 3. Let us quickly finish off the important topics from module 2 and left out topics from module 2, and we will move on to the module 3 later on. Okay. So, in the next video we will be discussing about the inverse transformation as well. Inverse transformation, let us see what is that in the next video. If you have any doubt or difficulty, you can ask at any time. Okay. Thank you for watching.